Bismillahir Rahmanir Rahim. Hi everybody. My name is Salah Al Bashir from Salah Al Bashir Academy. We will go together in a journey through the chemistry world. We will try together to understand the chemistry curriculum for the Cambridge IGCSE coursebook. Your curriculum is based on two subclasses, the core students and the supplements. The core will have 4 topics as this. Number 1 is the the distinguishing properties of solids, liquids, and gases. Number 2, describe the structures of solids, liquid, and gases in terms of particles, separation, arrangement, and motion. Number 3 is describe change of state in terms of melting, boiling, evaporating, freezing, and condensing. And number 4 is describe the effects of temperature and pressure on the volume of a gas. In addition, supplement students are going to take 2 more items or 2 more topics. Explain change of state in terms of kinetic particle theory, including the interpretation of heating and cooling curves, and explain in terms of kinetic particle theory the effect of temperature and pressure on volume of a gas. Our basic course book is going to be the chemistry of for Cambridge IGCSE, published for those 3 years actually, 2023, 2024, and 2025. We will go through each part of this book, and bit by bit we are going to deal with everything and with every segment in your class. I would like you just to pay attention and try to grasp the facts, try to manipulate those facts, and also try to increase your language skills, so the scientific language skill as well as the normal English language skills. Let us start our journey, and I wish you good luck. The name of our first chapter is the state of matter. So what is matter? The matter is anything that have a mass and take up space. The matter is anything that have mass and take up space. And when we say takes up space, that means it has a volume. We have 3 examples of matter. We are going to deal with this in more details, but here we just talk about them: the solid, the liquid, and gas states. And when we go forward, we will know more about them. So what is important here is the definition of matter, because you may be asked about that. So the matter is anything that have mass and take up a volume. Mass, you can weigh it, it is, in other words, anything that is tangible. You can feel it with your sense. Okay, let us go forward. So if matter is everything that have mass and can take space, what is a non-matter? Non-matter doesn't have a measurable mass and cannot be contained in a volume. So it is a vice versa. They are forms of energy. So they are energy-like things. Energy means the ability to do work. Energy has neither a mass nor a volume. So any non-matter has neither a mass nor a volume. Matter can be converted into energy and vice versa. Like, for example, the heat. We burn wood and then we get energy. Matter, energy are often found together. So matter and energy, matter and energy, matter and energy are often found together, and an example of this is fire. So fire is an example of the presence of both of them together. Examples of energy here like light, heat, and sound. All of them are only energies, but you can't measure the light. You can pick it in a place and then you weigh it, or you measure it with a ruler or anything like this. Also the same thing as heat. You can't measure the heat. You measure the temperature, but you don't measure the heat itself. Sound also, because those are energies. Matter could be classified in different ways based on many facts or many factors. For example, we can divide the matter according to its physical states, like solid, liquid, and gas. We can also, based on their shape and arrangement, we can do that. We can make this type of classification, that how they are shaped and how their particles are arranged. Also, based on their mass and volume, we can do that. Also based on the movement of its molecule, and all these together are very important because we will deal with the with each matter based on its characteristics, and based on these characteristics we will see how this matter appear to us. Matter is classified based on its physical states into three distinguished classes: solids, liquids, and gases. And all of them have mass, and also can take up space, whether it's solid, liquid, and or gas. And based on this, we are going to study all other things. Based on the classification of matter into solid, liquid and gas, we will try to distinguish the properties of matter and the properties of each class of them. Each type of matter, we will see how it ranks and how it works. However, there are different types of properties. We will have eight properties. So we would like to know how they are differ in these things. The first two are the shape and arrangement. The first two properties. So if we try to compare them together, we will see that solid has a definite shape. For example, this USB, it is solid and it has a specific shape. We can't change this shape unless we break it or melt it or do anything else. But if it is like this and spent in the room temperature, that it will not be changed. It has a definite shape. Compare this to liquids. Liquids, they do not have a definite shape unless you put them into a container. They take the shape of the container. If the container is cube, it's going to be a cube shape. If the container of the liquid is round flask, it's going to be takes the shape of the round flask. If it is a conical flask, it is going to take the shape of the conical flask. If it is a plain bowl, it's going to take the shape of the plain bowl. So it has no definite shape unless you put them into a container. If you put the liquid into container, it's going to take the shape of liquid. If I put a liquid here, it's going to be cylindrical in shape like this vial. Okay, what about gas? The gas has no definite shape, and also it doesn't take the shape of the container, because if you put it, it's going to get out of it. So unless you close the container, you tied the lid of the container, and you close it, you shut it down, it's okay, it's going to take this. But if you leave it free, it's going to be outside the container itself. So this is about the shape of the three statements. Okay, what about the arrangement? What do we mean by arrangement? We mean the arrangement of the particles of this matter. We will try to describe how these particles are arranged together to form the solid or liquid or the gas. So in case of solids, the particles are tied to each other like this, like we have put it here. You see here? So it is very tied. There is no big space between them. So we will see in how this affect their movement when we come to movement. This, in case of liquid, it's going to be okay, close together, but they are not packed or tied together. So they have some sort of free movement compared to solid. However, in case of gases, they are far apart. So there is a big space between a particle and the other. So in case of solids, those are tied together. They are not, there is no big space between them. They are packed together. In case of liquid, they are a little bit close together, but they are not packed. In case of gases, they are far away. So this is very important. Let us go and see the attraction of the particle together. Since there is two particles in the vicinity of each other, they are neighbors in a way or another. Those particles have an attraction power between them. They have an attraction power between them. So the attraction power of the solid are the most stronger. The particles are strongly attracted to each other, and particles cannot pass its neighbors, hold together by strong force. And this is very, very important phenomenon, that the attraction force between the solid particles are the strongest attraction force. However, when we come to liquid particles, they are attracted to each other, but still not like the solid, and they cannot pass each other, but they can collide to each other. Particles are a part of the gas and can pass each other because there is an ample space between them that allows particles to move freely and can pass each other. Those three differences are very important: the shape, the arrangement, and the attraction of the particles. Based on this, we are going to explain all differences between them, especially when we come to temperature effect or pressure effect and so on. We have another three properties added to the above three properties, or to the previous three properties, and those are the volume, the density, and compression. In the first three properties, we see the shape, the arrangement, and the attraction force between them. Here we are going to see the volume, density, and the compression. So this solid has a fixed and definite volume. Fixed and definite volume. If it is 1 kilogram, it is 1 kilogram. If it has a specific volume in the space, it's going to be this specific volume. It's not going to be more than that for any reason. So this is important. If we try to figure out the liquid, it has also a fixed and definite volume. It's not going to be expanded. However, this is not the case in case of the gas, because it has no fixed and definite volume. It expands to fill the container, and if the container is open, it's going away from it will flies away from the container. Based on the density, which is the second one, the solid is high density, the most one that is dense. It has the liquids have a moderate to high density based on the type of liquid. If we talk about the water, it is just a moderate dense. If we talk about mercury, which is a metal, it is a high dense compared to water. Gas with the lowest density. So be careful about that. Sometimes you may be asked about which one is more denser than the other. Compression. If we press on solid, gas, and liquid, is there any differences? Yes, there is a lot of differences, because it is not compressible. Compressible in case of solid is slightly compressible compared to solid, and highly compressible for in case of gas, because there are large spaces between the particles which allow them to come closer to each other, and this is not the case in case of solids, never the case, and to some extent it is not the case in case of liquid. The last two properties that complete the eighth property are the movement and the fluidity. Both of them, they may appear the same, but there is some differences between them. So solid are not movable, no movement in them. The particles never pass each other because there are no enough spaces between them, and so they are vibrating. They vibrate. They vibrate. They do not move very quickly or move very fast. Liquid are controlled. They have very restricted movement. Particles cannot pass each other. However, there is little movement between them. Gas particles move freely and randomly and can pass each other. Based on this movement, solid does not flow. However, liquid flows easy, and the most easier one that flows is gas. By this, we finish the eight properties. All of them are important, and all of them distinguish how the matter in front of us, is representable and how they behave. For example, when we have this, it's not like the border, and so on. Now let us ask ourselves a question. If those are the three state or the three physical states of matter, if this is the case, is there anything that makes them interchangeable? I mean, can solids turns into liquid, and liquid turns into gas, and vice versa? And what are the factors that are responsible for this? Yes, they can change into each other. Each state could be changed into the other one. And the main two factors are the temperature and pressure. Temperature and pressure are very, very important factors that change the status of each state of matter. So each state of matter could be changed based on those two factors. So solids can melt by temperature, gives liquids. Liquids by temperature can evaporate and gives gas. Not only by temperature, but also by pressure. If change of pressure and temperature happens together, solids may melt into liquids, and liquids may evaporate into gas. If we reverse the condition and we, instead of heating it, we cooling the one. So by condensation, gas could be turned into liquid, and liquid by freezing could be turned into solids. The most easiest thing is, in this case, we can have ice here, and then ice could melt at room temperature or at 0 degrees centigrade into water, and then water at freezing at zero, cooling it at 0 degrees centigrade is going to be turned into ice. If we heat water to boiling, then it's going to evaporate. And if we condense, the evaporation is going to be at lower temperature, is going to turn into water. Okay, does solid turn into gas or vice versa without passing the liquid state? Yes. This is called sublimation, and solid may sublimes to gas based on the temperature and pressure without passing the liquid. Also, if we do the same thing for the gas, okay, it calls also gas can sublimes into solid, and we will see how this happens in when we go further. Now let us see how this happens, the changing from state to state, how it happens, and how the temperature and pressure allow this change. I mean, how they are the factors. So melting or fusion, it is the same thing. Melting is the physical process of liquefaction of solid substances into a liquid by heat. By heat means by raising the temperature. Melting point, which is at the point, the temperature point at which the solid melts, is the temperature at which a pure solid substance is turned into liquid. I'm going to see the remarks of number 2 and number 1 together. Now, freezing is a solidification. When we become freezing, we say freezing. This is a sort of solidification. Freezing is the physical process of solidification of liquid substance into solid by lowering its temperature below the freezing point. The freezing point is the temperature at which pure liquid substances turn into solid. And why we say pure in both of them? Because if there is an impurities or contamination with other materials, this will change the melting point and also will change the freezing point. So here we strict on when we define the freezing point, we strict on pure substance. Now, what are the remarks for the both melting and freezing points or freezing processes? The melting and freezing points of pure substances are the same temperature. Example, pure water. The melting point equal the freezing point. Both of them are equal to 0. Gallium, which is an element, melts at temperature just above the room temperature. And at the same time, it freezes the same point. Dry ice, carbon dioxide. This is the sublimation. The sublimation is the physical process in which pure solid substances turn into gas without passing through the liquid state by heat and normal pressure. And we have it as dry ice, which is a carbon dioxide that compressed by pressure and temperature, lowering its temperature, it is solid, and when you come into the room temperature, it evaporates as gas, or sublimes as gas. Iodine also turns into iodine gas when it is heated without going through the process called the liquid state. Three more things that we have to take of them, three more properties actually due to temperature and pressure effect. The evaporation or vaporization, the same, they are synonym to each other. Evaporation is the physical process that changes liquid, example water, to gas, example water vapor, by heat. So evaporation is a phenomenon that is restricted, or a physical process that is called the change of a liquid into a gas by using heat. And heat here means raising of the temperature. The larger the surface area, if the surface area is large, the faster the liquid evaporates, which is a very important remark. The higher the temperature, means warmer liquid, the faster the liquid evaporates. So why this? Because it is, all of it is about the make a room between the space, make a distance. You see the particles, what you do with the heat is to increase the spaces between the particles. Whenever you increase the spaces between particles, you allow the movement of such particles, and this will change state to other state. The same thing, if you reduce the space between the particles, you reduce the movement between those particles, you make state B to turn into state A. So it depends upon which state you want to change it into other state. A volatile liquid is the one which evaporates easily and has a relatively low boiling point. Water is 100 degrees centigrade or Celsius, and or ethanol 78 degrees Celsius. That means at this degree, the liquid evaporates easily. If it is higher than this, it is not a volatile. What are the factors affecting evaporation? The surface of the liquid, the temperature, and the pressure. So the three factors that are responsible for evaporation. Be careful about that. Again, boiling is the same thing. The boiling point is the temperature at which vapor pressure is equal to the standard sea level atmospheric pressure. What is the standard pressure? Is 760 millimeter of mercury. It is also called the standard pressure. The higher temperature, the faster liquid boils. Again, why? Because whenever you have heated the liquid, the spaces between the particles are going to be more distance. It's going to fall apart, and then it allows free movement. Why? Because the force, the attraction force between them is changing and become weak, and when it becomes weak, it is going to evaporate or boils. The lower the pressure, the lower the boiling point of a liquid. So in high altitudes like mountain, the boiling point of water is less than 100 degrees Celsius. Why? Because very easy. It condenses more. It comes down. The higher pressure, the higher the boiling temperature. Example, cooking pot. The boiling point of water in a cooking pot is around 120 degrees Celsius, not 100, because you increase the pressure. So the factors affecting boiling point are temperature, pressure. Be careful that water boils at 100 degrees Celsius, which is 212 degree Fahrenheit. Condensation. Condensation is a physical process that changes gas into liquid by lowering the temperature or changing the pressure. And this is very important. So the two factors that affecting condensation is the temperature and pressure. In a couple of minutes, we would like to wrap everything. That the three main states of matter is the solid, gas, and liquid. Matter is everything that or anything that has a mass and take a space, that means a volume. There are some factors that affecting the status of each matter, which are the temperature and pressure. What they do actually is that they either change the space between the particles, so they make reduce the attraction power between the particle. They make the particles more free to move when you heat the temperature or increase the pressure. If you do the reverse condition, that means you cool or you reduce the pressure. What you are going to do is just you are going to reduce the space between the particles, increase the attraction force between them, do not allow particles to move freely, so you make the reverse condition. We also studied the different shape of the matter, solid, liquid, and gas. Also their arrangement, the particles arrangement, and the attraction force between them. We also see the melting point, the condensation, the melting, the freezing, and the melting point and freezing point. And also we see the sublimation, that means the transfer or changing of the solid into gas or gas into solid without passing the liquid states. And we do all this together in order to perform a good class for today. So I really appreciate your listening, your encouragement, and also I would like to ask all of you, if you have any question, you just put it, write it down directly into my under the comment and make comment for that, asking for what you want to do, and we will go together one by one to understand everything. I will review your remarks and see what's going on. Thank you. Again, I appreciate. Have a good day.